So yeah, I made a Star Wars table. Let's see how it was done.
If you're watching this video, there's a good chance you grew up loving Star Wars. And you probably remember the first time that you saw the opening credits scroll. All of a sudden, you were turning any broomstick you could find into a makeshift lightsaber. For me, it was the summer of 1983 when I saw Return of the Jedi in theaters. From there on, I was hooked, and I figured it was about time that I incorporated some sort of Star Wars theme into one of my builds. I was playing with the idea of a table with LEDs under an epoxy inlay, and it came to me, Death Star lights. And with that, this project was born. So far, you've just been watching me create the melamine portion of the concrete waterfall form, and I've gone through this in some other videos, so we're not going to go into detail on it here. We've got a lot to get through. Concrete, woodworking, epoxy pour, electronics, LEDs, 3D printing. You get the idea. There's a lot going on, so we're going to keep it moving. And with all this going on, let me give you a quick overview of the whole design so you've got that context throughout the video. The table will have two primary portions, a concrete top with epoxy inlays that are backlit with addressable LED strips, and a wood base, which is essentially a smaller waterfall table that follows the inside lines of the concrete. With this design, I kind of wanted to make it like a secret handshake between Star Wars fans.
You've seen Star Wars 27 times.
Something that every Star Wars fan would instantly recognize as being inspired by Star Wars, but that a non-Star Wars fan
I have never seen Star Wars.
wouldn't recognize as being Star Wars inspired and would just think it was a cool design. With the waterfall form constructed, I moved over to my X-Carve CNC to cut foam knockouts in the shape of the Death Star lighting. I used Fusion 360 to come up with the layout of the light bars that I liked, and then exported that layout to an SVG file that I could bring into Inventable's free easel software to cut out on my X-Carve. I'm becoming a big fan of this Fusion to easel to X-Carve workflow. It's relatively simple, but opens up so many creative possibilities. The foam knockouts came out great. I just had to do some quick cleanup sanding of the edges and they were good to go. As you might have noticed, I took advantage of the CNC to carve unique labels into each foam knockout. This made it simple to arrange the knockouts exactly as I designed in Fusion. Next, I could start actually adhering the knockouts with spray adhesive. And yes, spray adhesive will dissolve foam if you're too aggressive with it. But I found that if you got a light touch with it, this general purpose adhesive works pretty well.
So this actually went really pretty smoothly. I'm liking how it's looking. It's looking like Star Wars. So now it's time for Caulk Talk.
And for this Star Wars edition of Caulk Talk, I'm replacing the normal fondant ball tool with a caulk saber. And the caulk saber did the trick, pushing excess caulk to the sides and leaving a perfect caulk line over the seams. And the paste wax on the melamine allowed us to peel away the excess easily, leaving a perfect caulk line. Okay, time to switch things up a little bit. We're taking this form on a road trip out to Fishtone's training facilities.
We're going to the Dagobah system.
Tom Fishtone, the owner of Fishtone Concrete's, gonna help me pour this table, so I'm gonna get some tips from him and learn from a real pro.
Yoda.
Should be fun, let's go. When I arrived at Fishtone's training facility, we got the form set up and got to work mixing up the face coat, which we'll be spraying onto the form for a nice clean surface.
All right, so today what we're going to use is our HP50 mix. It's a base mix. It has sand, cement, pozzolan, and some mineral admixtures in it. The other important ingredient is going to be the polymer. The polymer acts as a film former, helps with the curing, helps with the flexural strength, etc. We're going to weigh out our water and our polymer. And I know that per bag I need 2.5 pounds of polymer.
Side note here, Tom was one of the pioneers of glass fiber reinforced concrete back in the early 90s, and my memory card is full of footage of Tom dropping pearls of wisdom. However, trying to squeeze all this detailed information about GFRC mix design and technique into this video, we'd be here a really long time. So for the sake of brevity, I had to cut a lot of great stuff. But I'm setting up a return trip to Fishstone to film a video on a simple GFRC countertop with Tom, and I'll get into way more details than I ever have before, so keep your eye out for that one. With that out of the way, let's get back to the Star Wars table and spray the face coat. We went over the face coat with chip brushes to remove any trap bubbles and then moved on to the backer coat. The backer coat and the face coat were essentially the same mix, a carefully measured ratio of Fishstone's HP50 bag mix, acrylic polymer, plasticizer, and water. There were two notable differences, however, between the face coat and backer coat. First, we added glass fiber to the backer coat, and second, we used a bit less plasticizer in the back coat so it would slump less and be easier to pack up the vertical surfaces. One thing I picked up here was Tom's technique of troweling the back coat up the vertical waterfall leg. Now I tried it and it's something that will require a bit of practice to get the touch right, but it's definitely something worth learning, I think, because it produced a much cleaner underside to the vertical leg. Once the form was filled, we scraped the concrete off the foam knockouts so we'd have less grinding and the foam would be easier to remove. We covered the concrete with a plastic sheet and foam insulation. The foam insulation retains the heat generated by the curing process and thus speeds up the cure. At the same time, the plastic sheet holds moisture in and thus keeps the concrete hydrated so the fast cure doesn't cause it to weaken. You kind of get the best of both worlds here. Looks like it's curing nicely, so we're going to take it outside really quickly and just grind off all the excess concrete. We ground down the bottom of the table before removing it from the form so we could use the sides of the form as guides for getting a perfectly flat underside. Now, flat bottom and crisp straight edges is particularly important in this project since the edges of the wood base will be running parallel to the bottom of the concrete. Next, we used a variety of tools to remove the bulk of the foam knockout and cleaned off any remaining bits with acetone. I didn't get any good footage of the acetone dissolving foam in the form, but I did get this. As a demonstration of what acetone can do to the foam, I'm gonna get out of the way so it doesn't burn my eyes out. Tom, show him.
How's that?
I think I'm melting.
Just look at that afterwards. Time to mix up the epoxy and do this pour. I'm using Total Boat's high performance epoxy with Mixol white pigment. When poured in a thin layer, white epoxy is a great LED diffuser and it should give us a glass-like surface that's evocative of that classic Death Star lighting. After the pour in the top cavities had hardened, we turned the table 90 degrees to pour into the waterfall leg. Now I forgot to pack Total Boat's fast hardener, so each half of the first layer took a few hours to harden up. Now rather than pull an all-nighter, I decided to head home and pour the second layer of epoxy in my shop. By the way, if you're wondering how I'm going to get the LEDs under the epoxy, well, I think I've got a pretty clever solution, but we'll get to that later. The second layer is clear, and the only reason we really need it is for strength. I wasn't sure how durable the thin white epoxy layer would be if unsupported from below, so I figured better safe than sorry. Next up, Concrete Christmas, removing the form. With the epoxy poured straight into the form, I was particularly nervous, scared, excited, curious, all at once. Okay, confessional time here. I forgot form release agent on the melamine, so hoping it doesn't stick to the melamine. Let's try and get this off and find out. Fortunately, the epoxy released with no issue. And while a bit of epoxy had squeezed under the concrete, the overflow was pretty minor. So interestingly, and bank error in my favor, the epoxy is not sticking to the concrete at all, so we can get most of it off without even sanding that spilled over here. Look at this. And another quick thing to share is just these patterns of veins or arteries that kind of got made in the concrete and epoxy here. Just check this out. It's like a coral reef or plants or something. Check this. After carefully peeling and chiseling off as much epoxy as I could, I came back to sand the epoxy flush with the concrete. For this one, I just took the sanding up to 400 grit. I then applied an acrylic sealer to finish off the concrete and epoxy top, and with that, we're about halfway through, so it's time for some woodworking. I'm going to try something new and use the Orion 950 moisture meter from WAGNER Meters, this video sponsor, to pick out the lumber for this build. So I'm going to start by measuring the equilibrium moisture content, or EMC, here in my loft for comparison purposes. So let's see what it comes in at. So here's EMC, about 8.1%. So I just arrived at my favorite local lumber store, and I'm taking the Orion 950 in with me so that we can pick out pieces of wood that are as close as possible to the ambient moisture level in my condo where this table is going to live. Where's the ash? Boom, boom, boom. You want to say hello to the YouTube?
Hello, YouTube. We're here at Owl Lumber in Des Plaines.
There you go.
All right, welcome.
Okay, calling an audible from the ash. I've been taking a look at the maple too, and I think it's going to work a little bit better. So we've got some maple here. 8.2. That's pretty good. Let's take that one. 8.0. That's a pretty good one. And that's a big one. So I was able to get two boards to make the whole table from, and they're at 8.2 and 8.6, which is super close to what we've got in my condo. We should have very little wood movement, very little need for acclimation. So let's go check out. And I know some of you out there are thinking, well, I'll just get kiln dried and that's good enough. Well, you can get good kiln dried lumber, but if there's a big difference in moisture content from the final destination EMC, then you'll still get a lot of movement. So thanks again to WAGNER Meters for supporting this video and channel. And now let's get back to the woodworking. Actually, we kind of already have because you've been watching me mill up boards while I've been talking. Nothing earth-shattering here. Now, I don't have a jointer, so I use a combination of a carefully set up track saw and my table saw to joint the boards. It's a bit more work than using a jointer, but as you can see, it can produce some really nice square boards, and you could even do this with a carefully set up circular saw. With the boards nice and square, I moved over to my miter saw to cut the boards to rough length. So got all the wood milled up and it's time for the glue up. One thing to note here, I'm actually going to leave a gap here in the middle board from the glue up. And this opening is going to give me some space to hide electronics for the LEDs under the table. I used the combination of my Domino and ROCKLER's T-Track clamps to hold the work down, which made prepping the boards for a stress-free glue up quick and simple. As I was doing this, I was just getting more and more excited for my new shop, which is coming soon. And I'm definitely going to do a dedicated T-track assembly table there. No more having to use the same table for concrete pours and assembly and everything else. On the topic of keeping my assembly table clean, I did my best to prevent further destruction of mine by laying out these XL glue mats.
Shields up!
I'll leave links to these and all the products I use for the glue up in the description below. After letting the glue dry overnight, I came back the next day to cut the top and waterfall leg from the panel, which will be connected with a miter joint for a clean modern look. After splitting the glue up into the leg and top with my track saw, I used my table saw to rip cut the two panels to 18 inches, the same width as the concrete top.
I wish that I had one of those sliding table saw extensions, but I don't. So I'm gonna have to make this 45-degree cut to make the miter joint with my track saw.
Before gluing the waterfall miter joint, I set up my ROCKLER router table with a 45-degree chamfer bit to put a chamfer on the lower edges of the wood. From a design perspective, the chamfer on the lower edges makes the panels appear as if they are extending outwards to meet the concrete. This, in combination with the reveal between the concrete and wood, makes the concrete appear as if it is floating above the wood base. Okay, enough design mumbo jumbo from me. Let's get on with glue up numero 2 for the mitered waterfall joint. It's pretty much the same drill as the last time. Dominoes for alignment, and then it was pretty straightforward from there. Of course, dowels or biscuits could also work. And in this design where the leg isn't load bearing, you could even go without reinforcement and just use glue and tape as a clamp. Next, I could cut the pieces for the front leg, or the non-waterfall leg of the table, whatever you want to call it. This U-shaped leg is comprised of 3 pieces, with the 3 sides of the leg being attached to one another with miter joints, and the upper ends of the leg being attached to the wood top with butt joints. I pre-sanded the individual pieces off camera before the glue up, since sanding first is easier than trying to sand in the nooks and crannies that exist after the glue up. And because I pre-sanded, I masked off the areas around the joints to prevent the glue from staining the wood. After the glue dried, I could remove the painter's tape, do a bit more off-camera sanding, and get to the most #satisfying part of woodworking, applying the finish. Now it's time for dessert on this project, the LEDs. I cut small links from the strips to match the links of the epoxy inlays. I also tweaked the links of the segments so that I'd have 66 LEDs in each row.
Execute Order 66.
For a controllable 3x66 matrix. So all these little segments of LEDs meant lots of soldering. Lots and lots of soldering.
I know it looks like a crazy mess of wires, but after like 5 hours of soldering, I think it's good to go. In order to put the LEDs behind the epoxy, I came up with what I think is kind of a clever little solution. So I've got these little 3D printed clips that I made, which basically will just snap onto the LED strips. And those will pressure fit right inside the LED channels, and they hold them in there pretty good. So let's get this in, and then should be ready to fire it up and give it a test. There's already so much going on in this video. I'm not going to go into a whole bunch of depth on the electronics, but I wanted to make this battery powered so that you wouldn't have a cord running to your coffee table. That just seemed kind of weird to do. So I'm just using an off-the-shelf LED controller for 5-volt addressable LEDs. And I'm running it off two 18650 3.7 volt batteries. They're at 7.4 volts output. And because of that, I had to put a step-down converter to make the voltage 5 volts going into the controller. So just hook all that up. And boom, we got battery-powered light for the table. I know this is Star Wars themed, but I had to get a controller that also did music syncing. All right, this is pretty cool. I'm enough dorking around. Let's get back and assemble this whole table. Home stretch, just gotta use some of the scrap lumber I didn't use on this base and ROCKLER's thin rip table saw jig to cut down some thin strips. They're gonna sit between the wood and the concrete and create a small reveal, which should be a really cool little feature. Off camera, I went and painted those strips black on the edges that'll show, and I made sure to put some painter's tape over the wood so that we can glue them down to the base.
And since the visible edges are painted black, the separation created by these pieces will make the concrete appear to float above the wood. And to attach the wood base to the concrete, I'm using Tapcon concrete screws, which require a special masonry bit. But this didn't go quite as planned.
Really? All right. Well, this sucks. My tape gave on me. I just went through the table.
You have failed me for the last time.
Now, we've all had moments of frustration like this where it's super difficult not to go to the dark side.
Release your anger.
But I'm slowly learning to channel my emotions and focus on the face. This time, I just had to use slurry to fill the hole and accept that there would be a small imperfection. Hopefully, most people would be staring at the LEDs instead of looking at that little spot.
So this one was a little bit different, a ton of work, and in the end, I'm just super geeked about how this table came out. If you dug it too, make sure you subscribe and bell, and smash that thumbs up button. Also, I got a playlist up there of a bunch of cool projects that I think you'll enjoy too. That's it for this time, and I'll see you next time.